right, this is the second of the three problems that I was going to do for you for your homework 25. It's page 380, 119. As you can see, you're assigned a very similar problem involving the cosine rather than the sine, problem 120. This problem says use your calculator, make sure you put it in radian mode, and then fill out this table. And what we're doing here is we're sort of investigating the limit as x goes to 0 of sine of x over x. And if we fill out the table, we can sort of talk about the results later on. As it turns out, this sine x over x is a limit that occurs often in calculus. Often it occurs occasionally in calculus. There is, in fact, a geometric proof of what this value tends to be. But I'll save that for another time and keep it out of this video. You can kind of see what's interesting here. The sine of x as x approaches 0. Think of the unit circle. Think of letting the ray kind of move down to the x-axis. As it does, the y component of, if you will, is getting smaller and smaller and smaller. I might just erase this embarrassing picture really quickly. But if you start with theta here, you've got a y value. This is the sine. This, remember, if this is 1, that length is the sine of this theta. Let me make theta a little smaller. Oh, now this length is associated with this smaller theta, smaller length. Let me make it smaller still. Sure enough, the length just keeps getting smaller and smaller. So clearly, sine of theta, or sine of x, is going to go to 0 as theta goes to 0. First, x goes to 0. And likewise, as x goes to 0, guess what? X goes to 0. So the top is going to 0, the bottom is going to 0. Can you make sense out of that? And actually, this problem is going to spoil you a little bit because you're going to find out that this limit is actually 1. But don't think that's always the case. This indeterminate form that we're heading towards, 0 divided by 0, it's named indeterminate for a reason. It's not 1 generally, even though it is in this case. So, got my calculator here. I've talked enough. I'm going to put 0.5 in. I'm going to store it right there. I'm going to take the sine. I'm going to get, is that a wrong answer? No, it's not. I'm going to get, I'll just do 3 figures here. I'm going to get 0.479. And then I'm gonna screw that up is what I'm gonna do. Got to do this a little quicker. Sorry. Recall 0. There's the sine. And recall 0 divide. There's this value, and it's 0.958. Okay. Let me just do half this table for crying out loud. You're gonna get the point here. Let me take 0.2. Store 0. Take the sine of 0.2. Should be smaller than this. And it is, it's 0.199 actually. But now let me divide 0.199 by theta, which we've taken as 0.2, and I get 0.993. All right, so this goes from 0.479 down to 0.199. This goes from 0.958 to 0.991. I'll put in 0.01 now. I'm going to take the sine of 0.01, and note interestingly, the sine is actually pretty close to theta. Theta is 0.01. The sine is pretty close to 0.01. It's 0.009, and if I divide 0.009 by 0.01, ooh, I get 0.9998. I better keep that 98. And let me go all the way out. Well, let me just go to here. Keep it every other one. 0.0001. Store 0. Take the sine of that. Boy, that's pretty darn close to 0. 0.0001 with a bunch of zeros after it. And if I divide that by 0.001, guess what I'm going to get? I'm going to get 0.999. 999. I can't count these numbers. 1, 2, 3, 4, 5, 6, 7, 8. 2, 4, 6, 2, 4, 6, 8. 2, 4, 6, 8, 8, and junk. Okay, so indeed, as promised, look at this. The limit, how do I want to write this? The limit, well, the answer to the question is that indeed the limit as theta goes to 0 of sine of theta divided by theta appears to be, I'm going to say appears to be, we didn't prove anything, but it appears to be 1. And in fact, as I said up here, we can do a geometric proof that shows that is the case. But maybe more interesting and maybe of more use to you STEM majors is the fact that for theta, what am I going to say, small, I'm not going to qualify that any more than that. For theta small, sine theta is about equal to theta. Yep. So there's the two takeaways from this problem. Problem 120 will give you similar takeaways on a related ratio here associated with the cosine. Right?